So, as part of the revision session of this operating system or else on operating system, first we are going to know the weightage of operating system subject with respect to GET examination, which is done by IIT Roorkee, right? So, if you consider it, in 2009 we have 13 marks of weightage of operating system, and in 2017 we have 7 marks of weightage for this operating system subject. So overall I can say 9 to 10 marks can be the average weightage we can expect from this operating system. So that is what weightage of operating system. So before going to see uh, the session, I mean revision session, recall what are the topics that we are having. So for example, if you consider the topics like, we are having majorly 4 topics here. We all know that according to syllabus, majorly we are having 4 topics, right? So what are the 4 topics? One is introduction to operating system, right? And other one is process management, and other one is memory management, and other one is file systems, right? Or else file management. So these are the 4 major topics that we have according to our syllabus, right? So then what is our methodology as part of this revision session on operating system is, we are going to work out on some questions. So I can say concept through questions, okay? So that is what we are going to do during this particular revision session on operating system subject, right? So before, I mean as part of this, let's see the first question which is related to. So first we are going to see some questions on introduction to operating system, followed by process management, followed by memory management. So like this we will be covering all the topics at max, okay, right? So as part of this, let's consider the first question. So try to go through this question and let me know what is the answer for this question. So this is very simple question with respect to the definition of operating system. You know that operating system definitions in our classes we have given around 5 definitions. If you can recall those 5 definitions, you can easily answer to this question. So what are the 5 definitions? Please revise yourself. We are saying that operating system is also called as resource manager. We are saying that operating system is an interface between the computer user and the computer hardware. And we also define that operating system is a set of utilities which makes application development easy, and operating system is a government of computer system, and operating system is a control program which can manage the computer hardware. So like this we have given around 5 definitions to the operating system. So if you recall these definitions, you can easily answer to this question. So please let me know what is the answer for this question. Yeah, exactly, good, Navya. Right. So the answer for this question is option C, I can say. Option C, right? Why? How you can say that it is option C? If you can recall, see, with respect to abstract view of a computer, we clearly define, and please recall the first definition explanation whichever we have given in our classes, like operating system is an interface between the computer user and the computer hardware. It means if you can draw the abstract view of a computer, you can draw like this. So what is the portion that you are having here? Computer hardware. And what is the portion you are having here? Which is computer user, right? In between these two, what we have? Operating system, right? So we clearly define what is the definition. So please recall the definition 1 of our operating system. It is an interface. It is an interface. It is an interface between the computer user and the computer hardware, right? So according to this definition, can't we draw this diagram? Yes, because in this diagram, I mean in this definition, you have only 3 components here. One component is hardware, another component is user, Another component is what? Somewhat interface. What is that interface? OS, right? So according to this definition, the abstract way of a computer can be drawn like this, and this OS is being resided above the hardware and bottom to the user. So overall it is the intermediate between the user and hardware. So hence we can say option C is the answer for this question. It is top of the hardware. Yes, it is the top of the hardware, plus as well as bottom of the user. Yes, it is bottom of the user. So that is why we are saying that option C is the answer for this question. Okay. So next. So I hope nobody is having doubt in this regard, right? So now we are moving to next question. Yeah. So please look into this question. Please look into this question. So this is the question. You know that operating system is an interface between the computer user and computer hardware. That's fine. But is the user directly able to interact with the hardware? No. That is possible via OS, right? Then how the user can interact with the operating system? So how the user can interact with the operating system? With the help of system call, right? With the help of system call. So this is what the point here. So user means here user application. User is developing an application. Let's say user wants to print something operating system on the computer monitor. Then what the user is doing? The user is building some program. So what is that program? We said it is called user application, right? So that user application, after building that user application, user is giving that application to OS. But OS don't understand, or else OS does not understand that particular program, right? Reason, that is in high level language. But OS does not know high level language, right? So which means that if you want to interact with the operating system, you required system call. So that is why system call is the answer for this question. System call is the answer for this question. So generally user applications can get the services from the operating system via system call only. And you know that system call definition in this context, what you have to recall, definition of system call you have to recall. What is the definition of system call? The first definition that we have given, that system call is an interface between the user and OS. And the second definition that we have given, that system call is a request made by the user program to the operating system in order to get any kind of service. We define these points, right? So system call, recall the definition of system call. What it is saying? So system call is saying that it is a request, right? Basically system call is a request. It is a request made by the user program, made by the user program to whom? To the operating system in order to get any kind of service. So based on this, you can easily say that option B is the answer for this question, right? So coming to the next question. So here you know that API is what? Application programming interface. See, basically system call is been invoking by your user application, right? Or else system calls are being part of your user application, right? And these system calls are transferring the OS services to the applications via API only. But basically we are working with the, the operating system is understanding system calls only. So that is why we are saying that system call is an interface between the OS and user, or system call is providing the services to the user applications, right? Via system call only, the user application can get the service or else can avail the service from the operating system. So that is why we are saying that it is option B. I hope nobody is having doubt in this regard, right? Right. So now we are moving to next question. Right. So look at this question, everybody. So producing the good response time is the goal of multi-programmed system or batch system or time shared system or none of this. So what is the answer for this question? You know that as part of types of operating systems, we discussed about batch system, we discussed about multi-programmed system, multitasking systems, which is also called as time shared system, multiprocessor systems, right? And real-time systems. 5 types of systems we have covered. So among them, if you can recall, which is producing the good response time among this multi-programmed system and batch system and this time shared system? Exactly. So the answer for this question is option C, time shared system, which is also called as your multitasking system, right? It is also called as multitasking system. So you know that in multitasking system, what is the main goal of the multitasking system? The main goal of the multitasking system is allowing the CPU to move from one process to another process in a timely manner. But what is the main goal of your multi-programmed system? Making the CPU busy always. That is the goal of multi-programmed system, right? But you know that the multi-programmed system is maybe non-preemptive or preemptive. If it is non-preemptive multi-programmed system, then obviously the response time or else the user responsiveness is very less comparatively your multitasking system. Reason in the multitasking system, the CPU is keep on moving from one process to another process in a timely manner. So which means the user applications are sharing the CPU with respect to time so that we can have good response. So that is why option C is the answer for this question. Okay. So now we are moving to next question. So look at this question. Making the CPU is always busy is the main goal of dash. Is a multi-programmed system, batch system, or both A and B and none of this? What is the answer for this question? So making the CPU always busy is the main goal of your multi-programmed system, but not batch system. Batch system, recall Nitin, what is going on in the batch system? While a process is performing IO operation, are you allowing another process onto the CPU? While a process is performing IO operation, are you allowing another process onto the CPU? No. In the batch system, you are not doing that activity, correct? You are not doing that activity. Yeah. So which means that there is some idleness is possible on the CPU. But in the multi-programmed system, what is the main goal? The CPU should be always busy with some work. It means that while one process is performing IO operation, the other process is allowed to perform its CPU operations on the CPU, so that the CPU is not going to sit idle. So CPU is going to become busy. So the main goal of multi-programmed system is making the CPU always busy. That is what the main goal of multi-programmed system. And the main goal of multitasking system is allowing the CPU to move from one process to another process in a rapid manner. That is the goal of multitasking system. So what is the basic difference between this multi-programmed system and multitasking system? So the multitasking system is purely preemptive system. Yes or no? Your multitasking system is purely preemptive, but your multi-programmed system is either preemptive or non-preemptive. Yes or no? Right? So this is what your types of operating system recalled. Okay, right. So then coming to next question. Yeah, look at this question, everybody. So what is the answer for this question? Spooling is the concept. Spooling is the concept where we have used. Yeah. So coming to the spooling, where we are using this spooling? In simple batch systems we are using. Option B is the answer for this question, spooling. So first of all, what is the meaning of spool? Please recall, what is the meaning of spool? Spool, which stands for simultaneous peripheral operations, simultaneous peripheral operations on line. simultaneous peripheral operations online. So this is what your spool concept, right? This is what your spool concept, simultaneous peripheral operations online. Then what is the meaning of spooling? What is the definition of spooling? The definition for the spooling is the process of placing the data in a temporary buffer, the process of placing the data in a temporary buffer for another program to execute. For another program to execute. This is what your spooling concept, right? So the best example for the spooling concept, what is the device that is comes under your spooling device? The best example is printer, right? Printer is called spooled device. Yes or no? Right. So because you know that if you give file 1 to print at time t0, that file 1 is having assuming that 100 pages, while the 10th page of this file 1 is in printing process. If file 2 if you have given, even though it is having only one page, so is your printer stopping the file 1 printing and taking the file 2 to print? No. Yes or no? So which means complete execution of the file 1 must be done. It means all 100 operations, 100 pages must be printed with respect to file 1, and then only it can take the second file to start print, even though the second file is having only one page. Am I correct? So this is what the meaning of spooling concept. So after complete execution of one process, then only the next process execution can be started. So that is why we are saying that if a process is having 10 units of execution, 5 units with the CPU and 5 units with the IO, entire 10 units must be completed, then only the next process execution can be started. That is what your batch system, right? So here the spooling concept we are using in batch system, but not in multi-programmed system and time shared system. In both the time shared systems and multi-programmed systems, while one process is performing IO operation, other process can go onto the CPU. But in the batch system, while one process is performing IO operation, the other process is not allowed onto the CPU. This is what, because the first process is not completely finished. So this is what your spooling concept, and this is what your batch system. Batch system, multi-programmed system, and time shared system. We spoken in our classes about uniprocessor systems, right? Uniprocessor systems, right? So now we are moving to the next concept. Next question, let's say. Yeah, so look at this question. With respect to multi-programmed system, it is clearly saying that with respect to multi-programmed system, which of the following is false? So processor utilization is increased, more than one process can be part of main memory, good response time, and all of the above. So what is the answer for this question? What is the answer for this question? Yeah, option. It is speaking about false. It is speaking about false. We need to find out false statement. Please mind this. We need to find out false statement. Please mind this. So what is the answer for this question? Yeah, so that is option C, because good response time is your multitasking systems, right? Your multitasking system. Good response time is the main goal of your multitasking system, but not your multi-programmed system. Yes or no? But these two, making the CPU, more than one process can be part of main memory. It is a feature of your multi-programmed system. Processor utilization is increased. This is also your feature of multi-programmed system only. Reason, while one process is performing IO operations, the other process is allowed to perform CPU operations. So that is we clearly defined it. right? So both are the features of your multi-programmed systems. But when it comes to option C, it is a good response time is the goal of multitasking system. Next, let's move to next question. So look at this question, everybody. What is the answer for this? So which of the following statement is false? Again, we need to find out the false statement. Please mind this. Statement 1, multi-programmed system attempts to increase the CPU utilization. And statement 2, in a time shared system, the CPU switches rapidly from one user to another user. Another user in the sense here my perspective is user application, okay. It is asking about the false statement here, it is asking about the false statement. Multi-programming system attempts to increase the CPU utilization. Is it true or false? It is true, right? It is true, right? It is speaking about the false. Multi-programmed systems attempts to increase the CPU utilization. Yes, it is true. In time shared system, the CPU switches rapidly from one user process to another user process. It is also true. Both the statements are true here. Yes or no? Both the statements are true here. So that option D is the answer. As both statements are true, none of the above is false. Option D is the answer. So for example, Dash operating system is used in home applications such as washing machine. What kind of operating system that we can use here? So you know that we are having two types of real-time systems. One is called hard real-time system and other one is called soft real-time systems, right? So hard real-time system and soft real-time system, if you look into, hard real-time system is not allowing the time delays, but your soft real-time systems are allowing the time delays, right? So what is the answer for this question? Yeah, exactly. Option B is the answer for this question, right? So it is allowing delays, right? How? Let's say in washing machine, I can set a timer for 5 minutes, and after that again I can change it to 2 minutes, or else if I set 15 minutes, I can change it to 5 minutes or 10 minutes. I can change it, right? I can do that time changes. Am I correct or not? But if you consider that rocket launching or its missile launching stations, once the timer is set, I cannot stop it. I mean, I cannot modify in between. But while in washing machine, I can do some changes. I can do some changes with respect to either rinse or wash or some other activity whichever this washing machine can do. Yes or no? So that is why we are saying that it is option B. So we are using soft real-time system in our washing machine. Okay, right. So then we are moving to, I hope so everybody is clear with this question. Option B is the answer. Which of the following statement is or false? Again, we are speaking about the false only. Again, we are speaking about the false only. Windows operating system is more convenient than Unix. Is it true or not? Yes, it is true. Windows is more convenient, more easy to operate than your Unix operating system. Then Unix operating system is more inefficient than Windows operating system. Is it true? No, this is false, right? This is false. Reason, you know that Unix operating system it is very robust comparatively Windows operating system, and Windows operating this Unix operating system allows multi-process system architecture also, but Windows in olden days it is not supporting the multi-processor system architecture, but Unix can do. And default a kind of security found a basic security is being provided by Unix operating system, but not Windows operating system. So based on all these points, I can say Unix is more efficient than Windows. But here it is given that Unix is more inefficient than Windows. Inefficient it is mentioned, which is not true. So that what is the answer for this question? Option B. Yeah. So now let's move to the next question. Yes, look at this question, everybody. Consider the following statements regarding the functions of an operating system in a computer. Which of the following above statements are correct? Verify. If you can recall the definitions of operating system, this question can be easily answerable by you. Yeah. So what is the answer for this question? If you can check, it is speaking about the functions of operating system. Operating system controls the hardware access. Yes, it is a function of operating system. That's why we clearly define the definition of operating system is it is a control program which can manage the computer hardware. Recall the definition. According to the definition, I can say statement 1 is the function of operating system. Then it manages the files and folders. Yes, it is also true, because you know that operating system is also called as resource manager. Resource manager. So resource here two types, like hardware resources and software resources. Files is comes under your software resources, which can be managed by operating system. That is why option 2 is, statement 2 is also a function of operating system. Then it provides user interface. Yes, it is also a function of operating system. Reason, you know that operating system is again definition 1. It is an interface between the computer user and computer hardware. So if you recall those definitions of operating system, this question is very easy to you, right? It manages the applications. Yes, all four are the functions of operating system, so that option D is the answer for this question. So for example, if I make it MSQ, for example, this is my option A, this is my option B, this is my option C, this is my option D. If I make it MSQ, then what is the answer for this question? If I make it MSQ, what is the answer for this question? It is going to be all, right? A, B, C and D. Everyone, everything. Am I correct or not? Right. So then we are moving to next question. Please look into this. So please look into this question. Operating system allows the CPU to operate in dash user mode only, kernel mode only, or both A and B. What is the answer? See, the answer for this question is option C, right? Option C. What we have studied, do you remember a heading of dual mode of operation? Are we studied this heading or not? Please recall. Dual mode of operation. What is the meaning of dual mode of operation? The meaning of dual mode operation is operating system is allowing the CPU to move from kernel mode to user mode and user mode to kernel mode. Are you forgot that? Have you forgot it? Please look into this concept, dual mode of operation. Operating system allows the CPU to perform both user operations as well as kernel operations. It can execute user instructions as well as kernel instructions. Yes or no? Recall, guys, what is going on to you? What is the point that we have given? Let's say I have a program like this. What is the program I am having? Something like main, and some I am having user instructions here. Then I am having some fork statement, and then again I am having some user instructions, and then if it is closed, then what is that concept that I have told you, or else what is the concept that we have discussed? Up to this, operating system is allowing the CPU to work in which mode? User mode, because these are all just user instructions. But when this particular privileged instruction, which is called your fork system call, is being encountered, then the execution of this program is moving to where? Tell me. It is moving to kernel mode. Am I correct? It is moving to kernel mode. So when this fork system call is being encountered, then the execution of the program can goes to kernel mode, because this is a system call, right? System calls are privileged instructions, and these privileged instructions will not be executed in the user mode. They can be executed in the kernel mode. So then this CPU is coming into the kernel mode. So during this execution of this fork, you know that it is a system call, right? So during the execution of this fork, let's say first before execution, what we are doing, we are performing compile time. So compile. So during the compile time, what happens? This is this fork system call, or else this system call privileged instruction is encountering what? It is encountering what? It is encountering. Recall the concept, guys. Recall the concept. So while this prerealize instruction is in execution during the compile time, it is encountering what? SVC. What is that SVC stands for? Supervisory call. And this supervisory call during the runtime, this supervisory call is generating what? It is generating a software interrupt. Have you forgot, guys? Please respond here. Software interrupt. So when there is a software interrupt is being generated, then you know that every interrupt is being associated with a separate program called ISR, which is your interrupt service routine. So this interrupt service routine does two activities. What are the two activities? It maintains the dispatch table. Yes or no? And it is also responsible to perform mode shifting. Are we not covered this topic? Please look into our notes carefully. We covered it. Very important concept it is, right? Very important concept we have covered. So what is this mode shifting? Mode shifting means allowing the CPU to move from user mode to kernel mode and kernel mode to user mode. And this dispatch table, what it contains, as it is a table, this table can have an entry format. What is that entry format? Privileged instruction means system call name and system call starting address. SN stands for system call name, and SSA, which stands for system call starting address. So this is the pattern of your dispatch table. So every system call can have an entry in the dispatch table. So from this dispatch table, let's say if it is my fork here, from this dispatch table, I can find the starting address of the fork and I can load it into the CPU, means into the PC, which is called the program counter, right? Then the CPU can start its execution by going to main memory. So after complete execution of that fork, right? After complete execution of that fork program, the last instruction of your fork is again allowing you to move from kernel mode to user mode. So it means your CPU is not engaged with only only user instructions. It is also engaged with kernel instructions. So that is what the meaning of dual mode of operation. So please revise the concept, guys. So it is both, right? Kernel mode of operations as well as user mode of operations can be done by CPU, which is directed by this operating system. Okay, right. So then we are moving to the next concept. Next question, let's say. Yeah. So what is the answer for this question? Dash is the result of multi-programmed system compared to simple batch system. Comparatively your batch system, dash is the result of your multi-programmed system. So the answer is option A, better utilization of CPU. Good. And what about the throughput of the system? Throughput of the system also a result of multi-programmed system only. Is it only A? Please verify. Both A and B, right? Better CPU utilization you can find. Am I correct? Better CPU utilization you can find. So that the throughput of the system also can be good, right? Shubhangi. A and B, right? It is an MSQ, right? Dash is the result of your multi-programmed system comparatively your batch system, in the sense, of course, you are making the CPU utilization is better, as which results more throughput. So that both A and B is the answer for this question. Okay, it is an MSQ question, right? So then coming to next question. Yeah, so please look into this question carefully. Primary memory is dash. So again I am telling you, right. So please listen to me carefully. I am saying that primary memory, it is also MSQ, not MCQ. It is also MSQ, guys, not MCQ. Primary memory in the sense what? Please revise your basics fundamentals. Primary memory in the sense, is it both RAM and ROM or not? Primary memory is your RAM and ROM or not? Please let me know. RAM and ROM are called your primary memory or not? Yes or no, right? Then what about your ROM? ROM is what? What kind of memory it is? Is it volatile or else is it non-volatile? ROM is what? And RAM is what? Yeah. So ROM is non-volatile. Yes, ROM is non-volatile. But what about your RAM? What about your RAM? This is non-volatile. Fine. Then what about this RAM? RAM is what? Volatile, right? RAM is volatile. ROM is non-volatile. So then what is the answer for this question? As I did not mention specifically whether it is RAM, whether it is ROM, I did not mention specifically, right? So since I have not mentioned it, what is the answer for this question? You can say A comma B, both. Primary memory can be volatile or non-volatile. So, but generally in our concepts, operating systems concept or memory management or CO concept, we generally consider the primary memory is RAM because mostly we are working with the RAM. But this is just a simple question, right? A simple question to test your fundamentals. See, primary memory in the sense both RAM and ROM are primary memory, right? Agreed with the point. So ROM is non-volatile and RAM is volatile. So both you can consider, but specifically it has to mention RAM. So if I clearly mentioned RAM, then what can be the answer? If I clearly mentioned RAM, then what can be the answer? Please respond to me now. If I clearly mentioned RAM, then what is the answer? It is very simple, right? Then the answer is going to be B, right? It is going to be B, volatile. It is volatile, right? So now we are moving to next question. Yeah. So look at this question. Which of the following operating systems is most reliable? So please respond. Which of the following operating system is most reliable among the multi-programmed system, multitasking systems and multiprocessor systems and simple batch systems? Among all of them, which is the most reliable? Yeah, exactly, Shubhangi. Good. Good, Nitin. Good, Shubhangi. So option C is the answer. Multiprocessor systems. How, on what basis we are saying that this is reliable? Recall what we have mentioned. This is a uniprocessor system, this is a uniprocessor system, this is a uniprocessor system. In all these uniprocessor systems, you are having only one CPU. If that CPU got failed, if that processor got failed, then you are not having any alternate way to execute the user applications or else user programs. But in the multiprocessor systems is more than one processor you are having, more than one CPU you can have, right? More than one CPU you are having. Physically, your system is going to have more than one CPU, but remaining all are going to have one CPU, right? Because these are all uniprocessor systems. We mentioned that these are all uniprocessor systems. Am I correct? This is a uniprocessor. This is also uniprocessor and this is also uniprocessor. In all these uniprocessor systems, as you are having only one CPU, if that CPU got failed, then obviously there is no alternate way to execute the programs. But in the multiprocessor systems, you are having more than one CPU. So if one CPU got failed, the execution of the process will not get stopped. It can be continued with other CPUs. So hence we are saying that this multiprocessor system is most reliable. So recall, guys, everybody, what are the advantages of your multiprocessor systems? Advantages of multiprocessor systems. Please revise. Advantages of your multiprocessor systems. Please revise. So the first one is reliable. Second one is economy, right? Third one is fault tolerant system. Fault tolerant system. Yes or no? And resource sharing. So like this we have given some advantages, right? And better throughput, you can say more throughput, better throughput. So we have given in our notes, please verify. So these are the multiple advantages of your multiprocess systems. Yeah, economy, less cost, which is cheaper. Okay. So by keeping this, by recalling this point, you can easily answer it is option C. I hope everybody clear with this question and its corresponding explanation. Right. So let's move to the next question. Yeah. So look at this question. Carefully look into this question. The question is clearly mentioned that which combination of the following features must be, please mentioned, clearly defined, must be suffice to characterize an operating system as a multi-programmed operating system when compared to batch system. I clearly mentioned, see, if you are recalling your previous year gate question, here it is mentioned that which combination of the following features will suffice, okay, will suffice to characterize an operating system is a multi-programmed operating system. But you don't have comparative batch system and not must. There it is mentioned that will only. Please revise your previous year gate question and this question, and it clearly saying that it is must be suffice comparatively batch system, comparatively batch system. So the answer is, you can say that option B, right? Option B is the answer for this question. Option B is the answer. Option B, guys. How? Look at here, more than one program may be loaded into main memory at the same time for the execution. Is it the feature of both multi-programmed system as well as batch system or not? Please confirm. Please confirm, is that feature of both multi-programmed system and batch system or not? Yes. Then look at this question. Look at this statement too. If a program waits for certain events such as IO, another program is immediately scheduled for execution. Is it exclusively batch system or it's exclusively multi-programmed system? Yes, it is only multi-programmed system. It is not a batch system. Yes or no? It is not batch system. It is exclusively multi-programmed system. Right. Then coming to this one. If the execution of a program terminates, then another program immediately scheduled for the execution. This can be happened in both multi-programmed system and batch system. Yes or no? It can be happened in both. But the question is clearly mentioning must be suffice to characterize an operating system is a multi-programmed system. Then what could be the answer, guys? Is it not option B? I clearly define that comparatively batch system. This is the one modification that I have done, and must be suffice. I changed the question, but previous year gate question you check. It is simply mentioned that which combination of the following features will suffice to characterize an operating system is a multi-programmed operating system, but it is not in comparison with any other operating systems. It is not mentioned that line or something. But according to this, the first statement and the last statement both are the features of multi-programmed system as well as batch system, no doubt. But the second statement, if you can check, it is only option B.